My live streaming to YouTube is not working. This has just been a day full of adventures and mistakes. So it's going to take me a lot longer, guys, to get today's recording up because I'm just recording manually and then I'm going to be uploading later. So I'm really sorry about that. The video for this class will be up much later than usual, but I am recording, so it will be up later. All right, so whew, it is what it is. We have an exciting day today, guys. We're leaving chapter 1, so we're leaving the basics of geometry and we're going into the basics of logic, which I think you guys will find really different than algebra. So hopefully we're going to have fun with that and doing that. All right. So the first thing we're going to do is we're going to name a pair of complementary angles. So we have to remember what complementary means. So complementary means add to 90 degrees. And I remember that because there's only one P here, right? So if there was two P's, that would be 90 and 90. So that would be complementary. And I see some people giving me some answers. Just a second. So remember when we're naming this, so we can't just look at this and assume that things are 90. So what we're looking for is we're looking for this. This box right here, right? Remember this box means 90 degrees. So that means angle BAD, right? So this big angle right there, that means that is 90 degrees. So if this is 90 degrees, okay, then I know that any smaller angles in it are going to be complementary. So I'm going to be taking a look at angle BAC. So I'm going to be angle BAC and angle CAD. Or DAC. I'm going to call it DAC. Okay. So these are going to be two my angles. Now, of course, we can name these angles differently, right? You could have said angle CAB instead of BAC, and you could have said angle CAD instead of DAC, okay? But what we're looking for is, because we know that this bigger angle right here is 90 degrees, then these two smaller angles are going to add up to 90, okay? And hey, it's good to make mistakes now, guys. That's what it's all about. So next, we're going to name a pair of vertical angles. Now, remember, with vertical angles, we're going to want to look for an X. There's only one X in this picture, and I'm going to highlight it in red. It's this, and it's this. Okay, so hopefully you guys can see that in the red, right? So I have this X. So for it to be vertical angles, it needs to be opposite angles, and there just isn't another X. You might be tempted to say this makes an X, but it doesn't go through, so we're not going to have opposite angles there. So the red here is my only X. It is going to be the only opportunity where I have opposite angles. So we could go top and bottom here. So that would be like angle BAC and angle EAF, angle EAF. Right, so that's BAC, that's this top angle right here, and then EAF, that's this bottom angle right here. Okay, so that would be a set of vertical angles. You could also go left and right, so I could do angle FAB, right, that's the one to the left, or I could do angle CAE. Okay, so those, again, you can switch around the first and last letter and have the same answer. Okay, so vertical angles, we're looking for those X's, right? So here I could do top and bottom, or I could do left and right. Okay, and I hope you guys are doing okay. Again, if you have any questions, or you can type into chat, or you can turn on your mic and ask as well. Okay, not a big deal there. And then this last one, it says, well, what if angle CAB is 42 degrees? So that is, if this was 42 degrees, then what would be the measure of angle DAC? Well, if you guys remember earlier, those are complementary angles. So I'm going to know that angle CAB plus angle DAC is going to equal angle BAD. Now, some of you don't like using symbols. So all this means is, well, angle CAB is 42 degrees. We don't know angle DAC. And angle BAD, bad angle, is going to be 90 degrees. So how do I solve this? I'm going to go ahead and subtract 42 degrees from both sides. Again, I really strongly and encourage the use of calculators so you don't get arithmetic wrong. We get 48, so I get angle DAC equals 48 degrees. And that's my answer. Okay. All right. Does anybody have questions on the warm-up, about anything in the warm-up? Just remember, there's quite a few people who have missing assignments. You guys do not get marked down for missing assignments, so you guys just got to turn them in and get the points. And it's that straightforward. So make sure if you guys have missing assignments that you're getting them done. Also remember, if you turn in an assignment and you don't get a score that you like, you can email me and redo any assignment. You just have to email me to let me know you want to redo it. Okay? And as always, make sure you guys, if you have questions, come to my office hours, ask questions in class. I would love to help you out. We got lots of late people today. All right, so today we're going to be doing an intro to logic. Okay, so we're doing 2.1, and this is the basics of logic. Now, it's really important here that the kind of logic we're going to be doing isn't philosophy. So we're not talking about philosophers or philosophy, though that's a really interesting road to go down because, a long time ago, there was nothing called math. It was all just philosophy because people had, with the advent of farming and animal husbandry, people had a lot more time on their hands. So if you look at civilizations, right, hunter and gatherers, you had to work all day. Like it was just nonstop. You worked all day. That's how you got food. But once people start getting a surplus of food, then you start getting these villages and cities, and people had time on their hands. And with people having time on their hands, they were allowed to spend time thinking, right? They didn't have video games to play. They didn't have a cell phone to look at. They just sat there and thought. And that's where philosophy came from. And they called it natural. And then, so from philosophy, it's like, well, how does the world work? Like, why are we here? What's going on? And from that, the next thing that came about was something called natural philosophy. And natural philosophy is what we would call science. So science came after philosophy. And then they were like, okay, well, like, can we describe this motion? Like, I want to throw a rock, or like, I want to throw this javelin. Can we describe that motion? Like, why is it when I push Francisco that I also feel something in my hand, right? So they had all these questions, like, where does fire come from? What is fire? What is our place in the universe? And then it wasn't only until natural philosophy really got more advanced that math came out of that, okay? Anyways, that's not what we're going, though that is a super interesting topic, and I wish we had time to talk about it. But when I talk about logic, I'm talking like robots. Okay, I'm talking like robots taking over the world, making us slaves, and we have to communicate with those robots. Okay, so the kind of logic I'm talking about is the logic that we use in programming. So it's super important today that we're not talking about what ifs. We're not like, well, what if we're on a planet that doesn't have gravity? No. We're talking about, this is just basic logic. Okay, so everything we do, you have to think, okay, I'm a computer, I'm a robot, I have an input, I have an output. Okay? So it's everything we're dealing with is just in front of us. There's no what ifs, there's no life experiences, right? This is just basic logic. There's no emotion, there's no like life experiences. So just take everything at face value. Okay. So the way computers work is that you have an input and an output. Okay? Now, one way of doing this is called, this is often called, instead of input output, like a function like math, it's called a conditional statement. Okay, so a conditional statement is just saying, if this input happens, this output happens. So again, it's very logical. So if we see this, we do this. Again, we're robots. So a conditional statement is that some condition happens, some condition is met, and then something happens afterwards. So in computers, usually that's a positive voltage or a negative voltage, or a positive voltage and a zero voltage. Okay, but so where we're going to take a look at English conditional statements. Okay? And the way that these conditional statements work is it goes if blank, comma, then blank. Okay? And this is the base logic for logic. Okay? It's that if something, then something. Okay? So now these again are going to have fancy names. So the first one, and this is going to be kind of confusing, so I'll explain it in just a second, but it's if hypothesis. Now you're like, Krebs, that's not confusing. We use hypotheses in science. Well, you do, but this is a different type of hypothesis, and that's where it's a little confusing. So it doesn't mean the same thing that it does in science. All a hypothesis kind of means here is it's a condition. Okay, so you can kind of think of it as science. So in science, you create a hypothesis, and that's your guess at what happens. So you might say, hey, if my hypothesis is true, okay, then we get a conclusion. Okay, so if my hypothesis is true, then I get a conclusion. If my hypothesis is false, then I get a conclusion, right? So if something, if a condition, then I get a conclusion. Something happens, okay? Now, in math, you might be thinking like, Kraft, you're not going to get me to write these letters out like that. And I totally agree. That's way too many letters to write for a word. Like, who's making words, right? Okay, so in math, we call this P, and we call this Q. Now you might be thinking like, okay, P, I get there's a P in hypothesis, but why Q? Guys, this predates English, okay? So we have P and we have Q. So another way that we would write this is we would say if P, then Q. Now we're not going to do logic tables, but this is how logic tables work. So this is if you were if you're an engineer setting up a circuit, you would use logic tables to set up your circuit so you know you got the required thing at the end. Okay, so this is if P, then Q. If hypothesis, then conclusion. Okay, notice how my hypothesis is by itself. If is not part of the hypothesis, and the conclusion is by itself. It's not part of then. So if and then are always going to be there. It's the P and the Q that are going to change. Okay, so if I have some input, then I have some output. Okay, now important thing to remember here, if P is true, so if P happens, then Q must then be true. Okay, and students always struggle with this. They're always like, well, this one time when I was in middle school, this happened. It's like, no. If P is true, then Q must be true. We're just robots. We're not here to question things. We're not here to use past experiences. If P is true, then Q must be true, no matter what P is, okay? So if P is true, then Q must be true, okay? Because if P happens, then we're a robot. We're going to do Q, okay? Which, you guys have experienced this. Sometimes you have technology not doing things you want it to do, right? But it's like, hey, if P happens, I'm doing Q, even if it's not the right thing that happened. Okay? All right. So let's do a quick thing of this. So I might say, let's just do a basic one. If it is raining outside. Okay, so if it is raining outside, then my dog is sad. Okay, so if it's raining outside, then my dog is sad. Now, when you write this down, what I want you to do is I want you to underline the hypothesis and put a P, and I want you to underline the conclusion and put a Q. So here's my conditional statement. I want you to underline the hypothesis, and then I want you to underline the conclusion and label it as P and Q. We're just doing a little quick practice here. All right, so hopefully you did that. So remember, if and then are not part of your hypothesis and conclusion. So my hypothesis here would be, it is raining outside. Do you guys see how that's a condition? Like, is it raining outside? It's either a yes or it's a no. Okay, so I look outside and I say, yes, it's raining outside. So without looking at my dog is not in this room. My dog is either upstairs or downstairs in her downstairs bed. So I'm going to say my dog is sad. That is my conclusion. I don't even have to see my dog. I know my dog is sad. Now, some of you would be like, wait, I have a dog and it's been, I know, sad, right? So, and like you might be like, well, you know, my dog can be happy when it's raining. Remember, that's not what we're doing here. This is purely just logic. So if it is raining outside, then my dog is sad. So it's raining outside right now, so my dog is sad because she loves going outside, but she hates the rain. So she doesn't like going outside in the rain. Okay? So this is an example of what we're going to be doing. So I have my condition, and then I have my conclusion. Okay? Now, we don't have a lot of time, so I'm going to have to move on from this. Now, we're going to do a lot with this. Okay? Because computers, we do a lot of things. We like to manipulate things around and change the way they are. Okay? So what we're going to do today, that's our basic. And then all we're doing for the rest of the day is different things with this conditional statement. Okay? So let's take a look. Okay, so the first thing we can do with conditional statements is we can do a thing called negation. Okay? And yeah, negation looks a lot like negative, right? So we're doing the negative. So negation is, so the easiest way to do this in English is to add in the word not. Right? In math, we add in a negative sign. But in English, the easiest way to do this is add in the word not. Now, I'm going to have students in this class, and I know people outside of class that are going to tell me, well, in English, we don't always use the word not to negate things. Well, that's because English is really complicated. But I want everyone to know that I am not here to grade you on grammar. Now, I might correct your grammar, but I'm not going to grade you on your grammar. So with that said, we can just use the word not anytime we want to use negation. Okay? So let me give, so that's what we're going to do. So add in the word not. So let's do a quick example of this. I am happy. Okay? So there is I am happy. And then if we want negation, would be I am not happy. Okay? And so you guys can see there, I added in the word not, and I have now the negation. Okay? Now, I'm not saying that I'm sad, I'm just saying I'm not happy. Okay, so that doesn't mean, right? So you can't pull more information out of it. You can just say, oh, they're not this. Okay, so this is an example of negation. Now, another thing that comes up is double negatives. Now, people always misuse this, but just like in math, a double negative is a positive. Well, two wrongs don't make a right, but you still, if you have double negation, they cancel out. So let's check this example out. So you are totally not my friend. Okay, and I'm just going to warn you, don't talk to your friends like this, because people don't like to talk in double negation. Okay, so it might help here if I put a comma right here. So let's read this with the comma. You are totally not, not my friend. Now, if I just did this and I said, you are totally not my friend, then yeah, you would feel pretty sad. You'd be like, oh, crap, I thought we had something. Okay, so you are totally not my friend. But if I say, you are totally not my friend, what happens here is double negation, they cross out. They go away. So what I'm really saying is, you are totally my friend, right? So people don't like talking in double negation. It's not comfortable. But double negation, right? Double knots are canceled. So double knots go away. Okay. So I just really want and I always have students who think they're really cool and they try to always speak in double negation for the rest of the week. But people don't really appreciate it, so I'm just kind of giving you that warning now, okay? So a not, that's a double negation, okay? So that would be like, you totally do not have homework. Right? So yes, you have homework. That's what it means, right? So double negatives, they cross off, they go away. Okay, and we're going to practice that in a little bit. Oh, guys, stop giving me those sad faces. You're going to make me not happy. See what I did there? All right, so now that you know what negation is, we're going to do a bunch of stuff with this conditional stuff. Okay? All right. So we have 3 different things that we're going to do with our conditional statement. Now, obviously, in real life, there's way more than 3 things. These are just 3 that are really common in programming and really common in day-to-day life. Okay? The first one is going to be converse. Now, you're looking at this and you're like, Converse? Kraft, we're talking about shoes now? You're all over the place. What if I told you that Converse shoes got their name from math? Does that ruin Converse shoes for you? No, but they got it from math, Converse. So a Converse, I want to make sure I'm using the book definition for this. Okay, the converse is you switch the hypothesis and conclusion. So you switch your P and Q. We're going to have to do an example of this. So a converse is you switch your hypothesis and conclusion. So remember my conditional statement. So I had a conditional statement, and if I said, if it is raining, then my dog is sad. You don't need to write this down if you have it on the same page. I need to write it down because it's not on the same page. Okay, so I had this. I said, if it is raining, then my dog is sad. What color did I use? Okay, so if it is raining, so it is raining was my P, and my dog is sad is Q. So in logic, we often want to check our logic in different situations. So now, check this out. My converse, I'm going to switch my P and my Q. So I'm going to have if my dog is sad, then it is raining. Oops, raining outside. Oops, nope, I didn't say outside before. I just said it's raining. There we go. Okay, notice how this is my P and this is my Q. So my P and my Q have stayed the same. Okay, but I've switched them, and that's what a converse does. A converse switches the P into the Q. So now read this statement. If my dog is sad, then it is raining. So now you might be thinking to yourself, wait a minute, is that true? Like, if my dog is sad, it causes there to be rain? that would be quite the puppy, right? We would want to like get that puppy and make that puppy happy all the time, wouldn't we? Okay, so when switching things, we change the validity of the statement, and validity is a fancy word for the truthfulness. Okay, so and we'll talk about. We don't have time to talk about that today, but that's something to think about. Is it true or false? So if my dog is sad, it is raining, right? And you might think this is where your experience comes in. You might say, hey, my dog has been sad because I took its toy away. Or my dog is sad because their best friend was visiting and left, right? So there's lots of reasons for people and dogs to be sad. So that's what's going on with a converse, right? You switch the P and the Q. Notice how the P and the Q, how they switched. Okay, that's a converse. You're going to be taking statements and you're going to be switching the P and the Q. Okay, and as always, guys, if you have questions, please let me know. All right, what's the next one? The next one is going to be the inverse. Now, when I look at inverse, I look at the first two letters, in. Okay, because I always like to say you're going to add in the word not. So the inverse is like the negation. Okay. So let's look at our conditional statement again. Again, you don't have to write this down again, but I'm going to because I am a crazy guy. So conditional statement. So if I look at my original again, I say if it is raining. And I'm just using the same one every time, so it's easy for you guys to copy, right? You don't need to look at your screen. If it is raining, then my dog is sad. Okay? So that's my conditional statement. I just keep using the same one again because it's faster to copy it down. So again, the first thing I'm going to do is identify my hypothesis and my conclusion of my original statement. So this is my original statement. I'm going to underline the hypothesis. Okay, so that's my hypothesis, and then I'm going to, this says then, I promise, then I have my conclusion. Okay, so it is raining is my condition, my dog is sad is my conclusion. Okay, so then what we're going to do here is we're going to write the inverse of this statement. So my inverse, okay, is going to read if, okay, and then I'm not switching P and Q. So converse is when you switch them. I'm just going to add in the word not. So I'm going to say if it is not raining. So if it is not raining, ooh, and I should add up here, add in not to both. Okay, so add in not to both. Okay, so if it is not raining, then, so if it is not raining, then my dog is not sad. I mean, shoot, if this was true, I'd want to move down to Arizona or California or Texas, right? I'd want my dog to be happy. You know, I wouldn't want it to be because we live in the Northwest that my dog is not happy, you know? Okay, so if it is not raining, then my dog is not sad. Notice how the not goes into both statements. So the inverse in, I add in a not to my hypothesis, and I add in a not to my conclusion. Okay, so if it is not raining, then my dog is not sad. Now I'm gonna do one more example here, just because I think it's really important. So if I call this example 1, okay, there's one other thing that sometimes people make a mistake with. So let's do example 2. So I'm gonna need a new conditional statement. Conditional statement. Okay, so let me think of a nice, easy one. If I do not turn in my homework. If I do not turn in my homework. Do you guys see how I added in the word do not, right? So in English grammar wise, it would be weird if I said if I not turn in my homework. Okay. Then, so if I do not turn in my homework, then I am sad. There. Okay, again, there it is. So if I do not turn in my homework, then I am sad. There we go. I'm sure all of you just feel in a terrible place that you don't have your homework in, but you should, because you guys can do it. You guys can do this. Okay, so let's see here. I do not turn in my homework. That is my hypothesis. I am sad. That is my conclusion. Okay, so if I want to write the inverse for this, and I'm going to slow down just a second because I know sometimes I have a tendency to go too fast. So what I have here is if I do not turn in my homework, then I am sad. So I underline one with P and the other one with Q, right? My hypothesis and my conclusion. So if my inverse would be if. Now this is where things get tricky. Do you guys see I already have a not here? So there's two ways you can do this. If you are like Kreft, I'm super comfortable with English, then you can go ahead and just write it and do all your corrections at once. But if you're not like super cool with English and you struggle a little bit, and that's totally fine because I'm not here to grade you on English, then let me show you how to do this with just using our method. So I'm going to do, I'm going to insert a new not, and then the old not. So I'm going to add in a new not. So I do not turn in my homework. So see how I have a double not now. Okay, and then, and I saw someone sent me an answer. Give me just a second. Then I am not sad. Okay. So notice again here that I am writing in the nots for both. And I really like, in the example some students sent me with direct messages, you guys skip this step. And that's totally fine. So if you're comfortable with English and you're like, Kreft, I got this. A lot of people are going to skip writing down the double nots and they're just going to say, I do turn in my homework. So if I... And some people, right, I see one answer where someone even dropped do because Grammarly you don't need do anymore. That's totally fine. I'm not grading on grammar, okay? So if I turn in my homework, then I'm not sad. But this is really helpful, especially if English isn't your strong suit, to write it out. And then this is what I would accept. If you write it out and then go like this. I will give you full points if you do this, okay? Okay, so I do not turn in my homework is the same thing as if I do turn in my homework, then I am not sad. So that is an example of, right? This is an example of a double negation, right? A double negative makes it a positive. Okay, so if I do not turn in my homework, then I am not sad. And again, I don't recommend talking like this. If you think you're going to try to be cool and talk to your parents like that, they probably won't think it is as funny as you are, especially if they're already mad at you. All right, so that's inverse. In inverse, you add in a not, right? You add in a not to both, okay? And if you get a double negation, the nots go away, okay? Also not a good way to fix not problems on a boat. Just be like, oh, I'll just double knot it. That was supposed to be a joke. Okay. All right. Let's talk about contrapositive. This is our last one. Now, I don't know about you guys. This is probably going to date me a long time. But when I was a young kid, Contra was a really hard video game. But probably dates me just a little bit. All right. So contrapositive. So this is how I would remember how to do contrapositive. Do you guys see how awfully long this word is? Yeah, Contra is a cool game. Contrapositive. Okay, so contrapositive, it's the longest word. That's how you're going to remember it. So look at this word. Gosh, that's a long word. It does the most. So contrapositive is the converse and inverse. So it's both. So the contrapositive is the converse and inverse. So we're going to switch P and Q and add in not to both. Oops, sorry. So we're going to switch. So what's that mean? We're going to switch P and Q and add in not. I'm going to put quotes around not. So I'm going to add in the not to both. And when I say add in not, if you want to be fancy in your notes, what I'm really saying is I'm doing the negation of both, right? That's the fancy word. I'm doing the negation. Okay? So a contrapositive is both the inverse and the converse. So I'm going to, and it doesn't matter what order you do them in. You're going to do them both. So let's say my conditional statement and I hope I'm going at an okay pace. So my conditional statement is going to be, if it is raining, so if it is raining, then my dog is sad. Okay. So, well, and I also don't give my dog as long as walks in the rain because maybe I don't like walking my dog in the rain as much either. Okay, so if it is raining, then my dog is sad. Okay, so again, it is raining is still going to be my hypothesis, and my dog is sad is going to be my conclusion. Okay, so then my contrapositive, okay, my contrapositive, it's going to be, I'm going to switch P and Q, and I'm going to add in a negative. Okay, so I'm going to switch P and Q, so Q's coming first, but I'm also going to say my dog is not sad. Now, some of you might be asking, Kraft, what if I put the not in the wrong place? I'm not grading on grammar. So if you put the not in the wrong place, I'll still give you credit. So for example, if you say, if not my dog is sad, I'm still going to give you credit. Okay? What I'm looking for is, did you put in the negation? Okay? So, so if my dog is not sad, then I can say, it is not raining. Okay, so if my dog is not sad, then it is not raining. So if my dog is happy, then that means it's not raining outside. Okay? Okay. So that is what a contrapositive is. You switch P and Q and add the not into both. I know. I'm just saying I want to live in this world where my dog can control the weather like this. Now I just need a cat that can control the temperature. All right. So what you're going to be doing mostly in your homework, guys, is you're going to be writing. They're going to be giving you conditional. You're going to be writing conditional statements, and then you're going to be finding the converse, the inverse, and the contrapositive. Okay. Now because of COVID, right? We have a whole bunch of things that we're not going to be getting to. So with that said, I want to make sure that you guys get a little brush of what you're missing, because I have to do that. I have to make sure you guys are good to go. Okay, so a couple of things that you guys need to be aware of. Something that we don't. Okay, so one thing, and I don't even know if I want to write this down. When it's not COVID, we spend a lot more time talking about logic and doing more stuff with it. So one thing you need to know, if your conditional statement is true, your contrapositive has to be true. So what I mean by this, if this conditional statement is true, then the contrapositive is always true. So if it's true that it's raining, then my dog is sad. Then if my dog is not sad, then it can't be raining, right? So if the condition for my dog's happiness is the rain, right? So then if it's not raining, then my dog is not sad. Okay? So I know some of you are like, that doesn't make sense, but again, we're just robots, right? So in a robot world, the contrapositive is always the same validity as the conditional statement. Now, that you're not going to have to know that this semester, but if you go on in life, that's important to remember. These two are always going to be tied together. Okay? Now, the inverse and the converse, they aren't tied together. They can be true or false. Okay, so just because your conditional statement is true doesn't mean your converse is true. So for example, here, if it's raining, my dog is sad, it is raining. So this is not necessarily true because your dog could be sad because of something else. Here, the inverse, if it's not raining, then my dog is not sad, right? That doesn't have to be true, but it could be true, okay? But we're not going to be doing that this year. I just wanted to give a little shout out for that. When your inverse and your converse or your contrapositive are all true, those are called equivalent statements. That means equivalent, right? When you think equivalent, you think equal. So that means that they're all true. So equivalent statements are when they're either all true or they're all false. Okay. All right, so I just that's not going to be in our curriculum this year, but that's just something I wanted to talk about. You can do a whole learning thing just on truth tables. If you want to learn more about that, when you go to college, I would take a class called linear algebra. That is a class that usually talks about truth tables and programming and stuff like that. Okay, so some useful definitions. Okay, so now that we have this logic, how does it apply to geometry? So one is with perpendicular lines. Okay, so you guys know what perpendicular lines is, right? So that's when two lines meet at 90 degrees. At 90 degrees. Well, from now on, because we have this logic, we're going to use this kind of computer-like logic. We're going to put it into an if-then statement. So the way that this works is if we can say if line L is perpendicular. So if line L is perpendicular to line M, okay, then the lines meet at 90 degrees. Okay. So if the lines are perpendicular, then the lines meet at 90 degrees. And so this is our condition. Our conditions are the lines perpendicular? Well, if they're perpendicular, that means they meet at 90 degrees. And we can add a little picture here if you'd like. Okay, so if these two lines are perpendicular, then that means they meet at 90 degrees. Okay, so this is a way to get rules, to get laws, right? Because we have a logical statement. If this happens, then this is true. Okay, and that's where we're going with this. If we're going to prove things, then we need a set of rules and laws to play the game. Kind of like a board game. You have to know the rules. Okay, so that's how we're going to be using conditional statements. So again, we have our condition, our hypothesis, and then we have our conclusion. Don't spell conclusion with a Q from now on. All right, so that's what's happening there. Now, so this is just an example of what we're going to be doing. It's just weird because we have to skip a lot of things. So perpendicular lines is an example of a rule written as a condition, right? So if this happens, this happens. Now, one thing that, again, you don't need to write down, but the word is biconditional. Now think of the word bi. Bi means two, right? So biconditional, two conditional. It turns out this is biconditional. And what I mean by that is if you switch it around, so let's say I have if the lines meet at 90 degrees, then line L is perpendicular to line M. Now, did anybody notice which of the ones we just learned we just did? Right? This is a converse. So it turns out that if a converse is true and the conditional statement is true, it is called biconditional. Now, the converse and the statement aren't always true, so you're going to have to think about that, and we're not going to dive too much into that in this COVID year. But the point I'm trying to make is that if your original statement, if your original conditional statement is true and your converse is true, then it's called biconditional. And let's read this. If lines meet at 90 degrees, then the lines are perpendicular. Absolutely, it goes both ways. So if you know they're perpendicular, then you know that these angles are 90. And right, so what's really cool here, if this is 90, then we have vertical angles. This is 90. And then we have a linear pair. Do you guys see how these are all 90? Right? Using linear pairs and vertical angles. Kind of cool, right? So it's like what came first, the chicken or the egg? And here, it doesn't matter what came first, right? So if you knew that they were perpendicular, then all of these angles are 90. If you knew all the angles are 90, then the lines are perpendicular. Okay? So that's what biconditional means. Biconditional means that the conditional statement and the converse are the same. Okay? So I just really wanted to make sure you guys knew that one. Okay? All right. So those are my name drops. What we're going to do is we're going to end class with, I'm going to give you guys a conditional statement. And then I'm going to, it's 10:58. I got 2 minutes. Well, that kind of ruined that, didn't it? We're out at 11, aren't we? So so I was going to give you guys a conditional statement, have you write the inverse, the converse, and the contrapositive. So you do have homework tonight. It's on Big Ideas Math. I'm a little worried. I'm going to be reaching out to some of you guys this week who haven't turned in any assignments. Some of you, I think, are doing the assignments, but you're just not turning them in. It doesn't turn things in automatically for you. So when you're done with your assignment, make sure you take your mouse and you go into the upper right-hand corner of Big Ideas. Your name is there. If you click on a name, a drop-down menu comes down, and you have to hit submit when you're done. Okay, because there's quite a few people who haven't turned in an assignment yet, and I think that's why. I think you guys are doing the work, but you're just not turning it in. If you guys need help with your homework, I am available tomorrow from 1 to 3 p.m. Or 3:15 p.m. So make sure you guys stop by. But make sure you guys are getting that work done. So please get it done. If you need help, I'm here. You can also send me an email for help. But let's make sure you get that done. YouTube isn't working, so it's going to take me a bit to get this video up because I'm going to have to upload it. Okay? All right, guys. That is my end of class. You guys